Hello everybody. What this demonstration is going to show you is how to use the K5 IaaS autoscaling feature. But before we go any further into this presentation, I'm going to actually kick off the demo because the load balancer takes about 8 minutes to deploy. So let's jump straight into the K5 environment. I should have it open here. This is the K5 IaaS console. You can see here we've got no servers deployed yet. We've only got 3 public networks. So I'm going to go down to the stack component, which is OpenStack Heat, and I'm going to just drop a heat template in here. So we go over to the right hand side here, click on the plus sign to create a template. Autoscaler demo. I'm going to deploy my file. I have a local file. You can deploy by API, object storage, your choice. Nice and easy for me here just to drop it on. Like so, and then we'll give it 30 minutes. So all it's going to do, this is deploying the infrastructure as code. I'm going to go back now to the presentation while this is deploying and let you see what it's actually doing, or talk through what it's actually doing. So it's going to build up the whole infrastructure, which we will discuss now. So let's go back to that presentation. And if we kick this off. So who am I? So my name is Graham Land, and I'm a cloud evangelist, cloud technologist, cloud native architect, whatever you want to call me. Basically for the last 6-7 years I've been working in both the OpenStack world and the private cloud world. And obviously OpenStack and open source seems to be gaining momentum. I've lots of experience working with lots of different telcos, banks and that all around the world. Everyone who's testing and deploying OpenStack in anger. So what are we talking about here? We're talking about infrastructure as code. All the developer world, they're always used to doing continuous integration. When it moves to the operation side of the equation now, when we're trying to do continuous integration, originally we'd have lots of different scripts, different people would do things, they'd jump onto switches and that and make a quick change to get the application out into production. That doesn't scale and it leads to lots of problems, lots of downtime. So with infrastructure as code, what you do is all your configuration changes, all the actual infrastructure you build and that you codify. So you capture all that config files and scripts and you store them together in a repository where you can version control them. And what that means then is you have the application code and your infrastructure code and your configuration changes all kept together so that you can deploy, have a full life cycle of that. So you know when you go to deploy that application or recreate that application, you have version control on all of that. So you don't have any more situations where when you try to deploy code, it fails and you're spending the whole weekend trying to debug the failure. That's the vision, and that's what the Googles and Facebooks of this world, how they operate. What are we talking about? So we're talking about OpenStack Heat here on Fujitsu K5's OpenStack based platform. Anyone knows Heat? It's the orchestration project within OpenStack. And again, all the OpenStack projects are fairly similar to this picture that you see here. It'll have a database to keep state. It has a message bus, which is RabbitMQ for all the messaging between the systems. And then you can just, the stacks are our infrastructure as code. So the Heat stacks are the templates that we use to define the infrastructure within K5 and the K5 platform. And again, if we look, what does a template look like? What's the Heat template look like? Well, it's a YAML based file. So anybody who's familiar with YAML, you can get good linting applications to check that your constructs are correct, in the correct format. Heat templates, they have a version, and this version normally relates to whether it's an Icehouse deployment, Kilo deployment, and there's extra functionality and features that comes with that. Description, this is useful for when you deploy it, it'll be visible on the screen what it is. Input parameters, so this is what you have to change if you're going to follow along with this demo. So the input parameters are the prerequisites that the stack requires for your environment. Okay. Resources, that's what will actually get created by the stack. And then the outputs, so you can optionally generate outputs from a Heat file. If I just show you, I'll jump into the stack now in a minute. This is what we're going to deploy today. So it's effectively, if you look on the right hand side, so I'm showing you this is the UK region that I'll be deploying it in, but we'll be deploying it in availability zone 2, which in the stack is defined as UK-1B. And what we're going to deploy is this network, this internal network here is created automatically attached to that router that you see there. And also the load balancer will be generated automatically. The server will be generated automatically and put into the load balancer pool. Okay, so that instance will be attached to the load balancer pool. Now, what the auto scaling feature does is that it also sets up some ceilometer monitors and alarms. And when those monitors trigger either to scale in or scale out, it will, on the left hand side here, see this unit here, it will create, it will either expand or remove a load balancer. So sorry, a server, not a load balancer, an instance, depending on what the triggers, what the alarm event is. Okay, so let's look at the code. So here we go here, we got the top here. And up we go. So you'll see here, as I was mentioning, here's the description. Here's all the prerequisites that you must change. So everything under parameters you'll need to change depending on the environment that you're deploying it in. Also, if you're going to try and deploy this on a standard OpenStack deployment, it will not work. Okay, so Fujitsu supports standard OpenStack, but then it has also enhanced some components on top of standard OpenStack. So you'll see now this auto-scaling feature is unique to Fujitsu. Okay, so it's above and beyond your standard OpenStack templates. So you see there, they're the prerequisites. And the resources then, this is what actually gets created. So this is what it's building now as we speak. When you go in there, you'll see it's created a network, a subnet, connected them, tied them into the router, the existing router that was there. These are the security group settings. And then you'll notice here the IP address that I've put here. This is to allow my server to communicate into this demonstration. So instead of opening it all to the internet, I just go to a web page, go, what's my IP? And this tells me that the NATing to my IP address, this public IP address my server is coming out as. With that address, then you put that into your security group, and that means here that I'll be able to come in under SSH, and I'll be able to ping it as well, okay? Provided I give it a public IP address, floating IP address. And again, I've got another security group here for the load balancer. So with the load balancer, I only want people to be able to come in on port 80. So we can let the whole world hit the load balancer. So 000/0 is every IP address on the internet, but we're only going to allow port 80 traffic, okay? And again, it's only a demo, so you'd adjust to taste. Now we've got the server scaling pool. So this effectively defines the pool that will be used in the load balancer. So when you're trying to build up servers or add servers in and out of a pool, this is the web server pool that will be used. And you can see I've said that it must always have a minimum of 1 server here. And then in this scenario, I've said a maximum of 3. So that if the first server is continually triggered and overloaded, it'll keep building until it hits a maximum of 3. Okay. The next section here then is the launch config. And the launch config here is effectively the server that's going to get built and deployed. So it'll deploy one of these by default at start, but then every other instance is just a pattern, a stamp pattern of this image again every time it triggers. So it'll either add or remove, depending on the alarm that gets triggered, a server using this configuration here. So this is effectively what defines the server. This is the load balancer that Fujitsu uses to deploy it. If you look at my OpenStack Boston presentation, I go into a lot of detail on what we've done with regards to LBAS and the LBAS service. Again, it's unique to Fujitsu in that we can balance across 2 different clouds. So we can give your public load balancer will balance across 2 different availability zones. And those 2 availability zones are in different data centers. So they're different failure domains, several miles apart. I think about 30 miles apart. That's our load balancer. And then we've got the scale out policy. So we've got scale in and scale out policy. So effectively what to do when the alarm triggers, and we tell it adjust the scale by 1. Okay, and a cooldown period of 10. I think that's 10 triggers, 10 alarm events. And then the same here for when it's cooling down, when it's finished triggering, it's no longer under load, what happens? And you scale it by -1. So you effectively remove a server from the pool. And again, provided that there's always at least 1 server there. And then these are the alarms. These are what the alarms look like. So this is the alarm high. And this, we're using Ceilometer, the OpenStack project Ceilometer, and we're looking at CPU utilization. And when we look at CPU utilization, we just compare it to a threshold, we say 50. And if it goes over 50 for more than a minute, then if it's greater than 50 for more than a minute, then we want to trigger that alarm. And then that does the scale out, triggers the scale out event. And likewise then, the last part here is a Ceilometer alarm for the scale in. So when it goes below 15%, for more than a minute, then we scale it back in. Okay, so nice and easy, very straightforward. And again, that's all done for you. You just need to change the input parameters, and then this template will do everything for you. I'll just quickly, while I'm here, show you the server that I'm deploying. So the server that I'm deploying is just a standard Ubuntu server. And I'm just running this application. This application, I actually run it under port 80. So I don't run it on port 3000 here. That's the default one. So I'm running it under port 80. And it's all it does is just gives the server name. So when you hit that load balancer, when you hit the load balancer, it'll feed up the server, each different server from the pool, and you'll be able to see the different server names. That's all this is. Very, very simple, very, very basic. So that's the server that I'm going to be balancing. And again, this is just a script. If anyone wants it to be on the blog as well, this is how I wrap that Node.js application in a wrapper so that it just starts as a service on the Ubuntu box. So it might be of interest to people. So let's pop in and see what's happening now, how our system has done. So quick refresh here. As I say, it normally takes about 8 minutes. Okay, that create is complete there. So we go down and look at our load balancer. We should now have a load balancer. It should be in service. We see the load balancer is in service, so we can quickly test the URL then. Actually, here's one I made earlier. It's the same URL earlier on. And let's check. So you can see there the name of this server here. And if we just keep looping through that, you'll see that we can only see one server, okay? And then this server, if you look DEH5, if I go back to our K5 service and look at our virtual servers, here you go, DEH5, okay? And then I can also go to our load balancer and you can see it's the only server in the load balancer pool at the moment. So now what we want to do is we want to stress this. So we want to stress this server so that it goes across the threshold. Oh, keep going, right? Okay, so you can see DEH5, the server in the group. So as I say, the next thing, what we're going to do now is we're going to give this server a global IP address. So you wouldn't normally have to do this. This is just because I want to stress test the server. Sorry. So I just want to stress test the server. Back 2 seconds. So we go to our virtual server. And give it a global IP, which is a floating IP in OpenStack terms. In K5 terms, we call them global IP address. And it's a public IP address. And what I'll do is then I'll SSH onto that server because I've opened up the security group to allow me SSH. And then I'll just create a fake load on it. Oh no, wrong button, sorry about that. Cancel that. I want to go down to global IP. Allocate global IP. And I'll select my external network, which is an AZ2. There only is one. And there's the IP address I was using earlier on in my pool. Allocate global IP. And now I should be able to log on to that server. So what I'll do now is quickly SSH onto that server, which I have defined here as autoscaling. Yes, hopefully everyone can see that and read that. And then what I'm going to do is I'm just going to create a fake load on that. Stress is just an application, a simple application that lets you stress the CPU on your server, or you can do IOs as well. And I'll send that up to 80%. So that'll take a few minutes to come up to 80%. If I just open another instance there. And we can do a watch the uptime. And you can see there it's running at 17. So it needs to go past 50% before anything will happen. So we just watch that briefly. And what will happen when it goes beyond 50%, once the alarm is triggered, once it's that way for over a minute, so it's in breach for over a minute, it will kick in and deploy another server. And then another minute later, it'll deploy the next server until such time as the load is reduced on that server. So at 42 now, 45, 48, 50. So now the server is going above its threshold. So we look at the threshold set. We're down here now, we can look at the monitors, the alarms that have been defined. And again, these are all defined by the stack, showed earlier on the stack. So you can see there, two alarms, or sorry, the CPU alarm low and CPU alarm high. Again, all fine at the moment. The low one would have alarmed earlier when there was no load on it, but I've missed that. It's already checked it while it's gone above 15%. So it's not doing anything. The high threshold one will trigger now any minute. So I could try and rush that by doing an update. Back down here. Okay, so you see it's gone into an alarm state now. So what that means is that it's going to quickly now build another server. So if you look back at what we had here, the launch config. So it's running the launch config that we defined earlier on. So it's this section here, and it's effectively building another server. Okay, so we run into the K5 platform now, we should see another server getting built. And in here, virtual server. So see there, it's currently building another server. And if we go to storage, you can see it building the block storage. It'll be copying it down. Oh, it's creating. So okay, so it'll take a few minutes to create that storage. It's already downloaded. And when that storage is built, when we go down to our load balancer, it will add it back into the load balancing pool. And just like magic, you have your second server now in your load balancing pool. And then if you don't believe me, then we just go up and look at our external facing load balancer. And now if we loop through this, we should see these last server name here changing. Okay. So there you go, TV 36p and DEH5. 36p, DEH5. Okay, so that's it in a nutshell. So what we can do now is we can stop the scaling, so it will carry on building another server and another server until we hit our maximum of 3. So let me go back to our auto scaling and stop that stressing. Okay, so what that should do now is that should drop this back down. This should start reducing down. We've stopped the stressing application. You can see it's coming back down. Now it has to come down below 15%. So once it goes below 15% utilization, it will trigger. Okay, so that's coming down. And what that means then is that we'll start removing servers. So if we go back now and look, it's probably adding the third server as we speak. So we go back in here because it's still on scale up trigger. You can see there, so it's scaled up to the maximum. So there's 3 servers there. And then if we loop around this, you'll see 3 different servers now getting presented. Okay, so it's hit the maximum, so it's not going to scale up anymore, but because I've taken the load off that server, reduced the dummy load, what's going to do now, it's actually going to remove the servers from the process once it's been idle for a minute. Okay, ignore that. Okay, so again here, look at our alarms. Sorry, look at our server first, see what it's at. Still at 17, so it's not going to start triggering yet. It needs to go down below 15%, so that's 16. So now the load has gone down below 15. So it needs to be below 15 for a minute, and then it'll trigger. And you'll see it'll just remove the servers one at a time then. Monitoring alarms. So here you see they're both saying okay, so the CPU alarm high is back to okay now because the threshold isn't breached anymore. This one will go and fail now because it's below 15%. I'm just going to update that to speed things up a little. So rather than waiting for the minute for it to poll, I'm just forcing it to poll. Oh, patience is a virtue, Graham. Where are we at the tower? Okay, it's down to 5% now, so that should within a minute, any minute now. You can see go to alarm. Okay, and as I said, these two servers will be removed one after the other. Okay, so we've gone to alarm state there now. So we can get in time, we'll see those servers disappearing from K5. So yeah, you can see this top one's been removed now. Okay, and then again, the load balancer instantly is aware of this and will only show you the two servers that are available now. Okay, so all fully automated, nice and easy for you. That ends the demonstration. There will be a blog coming up on, blog and a video will be on the K5 Developer Center here. I'll also post it on my own blog, All Things Cloud blog, and on my GitHub repo. Okay, so a few different places where you can see it. Thank you very much, and this is a new format for me, so hopefully it's of benefit to everybody.